Hey, Dirty Plate, welcome to the stream. Hi, all. We're gonna see if how well the chat overlay is gonna work in this setup. I may have to disable it if it's distracting. Let me play with it a bit. Hey, Gecko. Yeah, so what we're doing today is I released a little bit of a new API with R and RBedrock last week. And so what I'm going to do is I'm going to give you a chance to ask me questions. Maybe I'll do some analysis or some programming here and try to work you through how to use R and RBedrock. This will be, I think, a good tutorial for maybe people who are catching up with this later on how to maybe use R and RBedrock, something to point people to. So we'll see how this works. First time sort of trying this sort of live outside of a classroom. Let me turn the music down a bit for me. Try it there. Yeah, so anything anyone wants to look at in particular, now's a good time to sort of start asking in the chat, and I'll see what we can get up to. So I'll give a chance for some more people to log in and ask questions before I start going over some of the changes that I've made with the new API in R and RBedrock. So yeah, so R and RBedrock is still in development, so the API is still changing a lot as I come up with better ideas on how I want to sort of express things. One thing that I've done with this is I've tried to get rid of sort of the $ interface as being in the the $ interface of being sort of used. So Cracked Magnet asks about how much crying obsidian is in a ruined portal. Yeah, so that's going to take some code digging. I'm probably not going to do much code digging on this stream, but it's something to sort of maybe ask in the code digging channel on my Discord and see if we can look into it. Let's do that. All right. So I think I'll get started. So when you're want to use all right. So one of the so the first thing when loading. So R and RBedrock is currently in development. And that means that if you want to install it and you're using R, you need to use DevTools. So this is all covered in my R Bedrock tutorial videos. But I'll go over a little bit of it today in case anyone is coding along with me or needs to update to match what I'm doing. So we do DevTools, install GitHub, HTTPS, install GitHub, read a Cartwright / RBedrock. So DevTools, install GitHub, read a Cartwright / RBedrock. So that's what you want to do in order to install RBedrock. So now I'm going to do Shift Enter to execute, Control Enter to execute it. And it's now going to go out to GitHub, download so down in here, it's going to download the source code and it's going to compile it and it's going to install it. So after that, we can then load our Bedrock into R and we can start analyzing worlds. So that's done. So now I'm going to do library, R Bedrock, and do Control Enter again, and that's going to load it. So we now have our Bedrock. So next I'm going to do a command called list worlds, Control Enter, and that's going to give me a list of some of the worlds on my system. And so some of these worlds are very small, not useful. You can kind of see some of the stuff I've been working on. And so the output of list worlds is a table or a tibble in our Bedrock, a tibble in like tidyverse kind of stuff. And it has 3 columns: ID, the level name, and the last opened. So the ID, this is basically the folder name in your primary folder directory. And the level name and last opened is stuff that is stored in the MBT for this world, and they tell you like the name of the world, that you saved it, or when you last opened it. Typically I'd use this to figure out the ID of the world that I want to open. So let me come up here and let's also load tidyverse while I'm at it. So again, Control Enter, loading tidyverse. Tidyverse is going to give us a lot of tools we want to use to work with this. So we have list worlds. And so list worlds, so like, if you look closely at my list worlds output, I have like 151 worlds locally in my local world directory. And so in our Bedrock, so I'm going to do one thing. I'm going to come over here. I'm going to save the results of list worlds to a DAT object. And then I'm going to come over here and I'm going to view it. And it's going to give me that same table, but in an easier way to look at it. So let's go to one of my larger worlds. Has a lot of stuff in it. I'll work on Tundra SMP. That's sort of a world that me and my kids play on. So I'm gonna come in here. I'm gonna highlight the ID and copy it, and then I'm gonna come back here and I'm gonna do db path, paste in that ID, and then I'm gonna do Control Enter to get that read. Then I'm gonna open db. So db is gonna be Bedrock db path. So that's going to now open up the database, which is an object. So DB is now an object that holds sort of a handle to the database in memory, so you can access it. So this is where our AP, so some of this you've seen is all sort of common, which is earlier, but this is where part of the new API takes effect. Used to be, the rule was if you want to close the database when you're done, you do DB close. That still works, but the recommended API now is close DB. So if you type close DB, the database will be closed when you're done with it. So that's sort of one API change. So I'll go back up here. I'll do Control Enter again to reopen the database. And now I'm going to get all the keys in the database. And to do that, the command is now get keys. So I can do get keys database and then do Control Enter. That's going to give me a list of all the keys in the game. So let's see if it's going to let me open it. It may not. So we can do something like, let's say head keys. So look at the first 6 or so keys, and we see we get a list of keys from the database. So keys like this here, with the ats at the beginning, those are chunk keys. So these are keys that point to chunk data. And the way chunk keys are structured, so the at tells you it's a chunk key in our RBedrock key terminology. This is not how they're saved in the game. They're saved in a different format in the game that's hard for us to really parse. And so I came out with this format to display them in a human-friendly way. And so this is your X coordinate of the chunk, the Z coordinate of your chunk. This is your dimension. So this 1 says this is another chunk. And this 44 tells us the type data of this. And of this data set. And 44 is version information. So Jerry Play says too much information. Yes, there's gonna be a lot of information here, but rewind it and rewatch it again after the stream's over, and hopefully it'll be there when you need it. Like I said, ask me things that you want to see me do, things that you've heard I've done. I'll try to do that. So let's see if I can. So the first thing I think I want to do is show you how to get a list of all your villages in your world. All right, village centers, say. So let me start a new file, and we'll do it in this new file. So I'm assuming that we're going to stick with the same DB. It's already been opened. So I'm going to make an assumption that DB is already open. All right. So next thing, so I'm going to do keys again, but I'm just going to get the village keys. And to do that, it's part of the new API. I can do this. Get keys, DB, village. Actually, I'll do it. Village. So Jerry Plays asked what program I'm in. I am in our studio. So if you look back on my channel, I have some tutorials about installing our studio and getting it up and ready to analyze Minecraft. So I'm gonna try this. I'm gonna do key starts with village. And then if I type keys and do Control Enter, I will print out all my village tags in this database. And you can see that we have, what is it? 1, 2, 3 villages in this world that have been generated. And so villages, they are known by having 4 tags. One saves the dwellers. So down here. One saves basic information. One saves information about players and POI. All right, so let's say we wanted to look at the info of a village. So we'll take key 2. We can talk about keys 2. And we can save it to data. What am I looking at? Get MBT value is the command. And so this is going to read, so get MBT value. So this is a function that's part of the new API. And what this is going to do is it's going to read one key from the database and parse it as an MBT. And if everything's working right, if I do this, I now have our DAT that's been loaded. So if I do Control Enter, we see that DAT is a compound MBT object. I'm still working on how these get all printed out. And I can tell some of these are not coming out right, like here, they're not coming out right. This one's off printing. And these are the values of the data. So if we wanted to say do names of MBT, maybe easier to do. I do Control Enter. These are all the elements that's stored as part of information about a village. Various ticking times. I forget what all these mean. This is the village VH time. That's the village hero time. So that's a timer. Other things are like the coordinates of the bounding box. I can't remember if it's what's important, if it's R or not the R's. So let's see if I can load up all this into a table. So let me check the one that's not showing up. So that's like BD time. Yeah, so it's displaying right here. So good. So we're hopefully it'll continue working. So I'm gonna take, next thing I'm gonna do is I'm gonna take like all the village info. I'm gonna make it into like a table. All right. So to do that, I'm gonna take, instead of doing I'm gonna do 2 things. One, I'm gonna now filter my keys so that we just get the info keys. So I'll call those I keys. And I'm gonna use a function called, remember correctly, str subset. Yeah. Actually, I'll change it without the pipe. str subset keys, and I'm gonna say info. Well, I should do info underscore info $. So this underscore info $, that $, so underscore info $, that is a regular expression in programming. So that's called a regular expression. And so what it's going to do, this str subset is going to return me all the keys, all the elements from keys that end in underscore info. All right. If I do enter and then I come down here and type I keys, enter, you see that we have our 3 info values. The str subset allowed us to filter for just our info keys. Now if we come up here and we do I keys and we do get MBT data, this is now going to return us a list of villages. So it's gonna see, so we have our, if I do, let's see if I do it like this, names, dat. Oops, names, dat. We see that there are 3 elements in dat that are 3 elements in dat that correspond to each of our info keys. So that's what MBT data will return. It will return a list of the MBT values, where the names of the list correspond to the keys. So it's kind of key value pairs, where it actually records the key and the values from the database. So it allows you to get multiple keys at once in a batch. Yes, Ninja Pigeon, this is me working with R. And right now I'm playing with reading village data in this. All right, so we've read this. We got our data parsed. And so the next thing I'm going to do is, and I think this is going to work, I'm going to do bind rows dat. Whoops. Names must be a character vector. Let's see what. So names dat. What is the type of names? Character. So now what don't you like? Oh, do I have to do an unclass? I think I have to do an unclass. All right. So now I think I'm going to do, see if I can get this to work right. Dat, let's go. Map, dat. I think this will work. Let's see. Let me see. Seem to work. Let me store that as a value. Give me a warning message, not sure why. Oh, and the printing. So if I now then look at that too, in here I see our villages information in a table form. We see I don't know what all these columns means. If old guy was here, I think he knows what all these columns means. BD time, GD time, MTick, PD tick, tick. I know VH time, that's a counter when you have a hero of the village after you defeated a raid. So I think one of these is probably raid time. Definitely here's the bounding box of the village. X0, X1, Y0, Y1, Z0, Z0, Z1. That's our village bounding box. So now, let's say we wanted to find the center of a village, which is useful, like if you wanted to, the center village is useful if you're building like a iron farm or something. You want to check that you got the center right in your map, and so that is pretty easy to do from here. So what we can do is use the mutate command. So let's do it like this. We'll do dat3. is mutate. Let's do transmute instead. Dat2. So x is going to equal to, if we remember our keys, it was what? X1, x0, y1, yeah. So we're going to do x0 plus x1 divided by 2. Y is equal to y0 plus y1 divided by 2. And z is equal to z0 plus z1 divided by 2. Do enter, and then actually let's do control enter, and then let's see input. Let's see what I do. Righty, right. I have not, because our columns are still stored as our MBT values. I can't add them yet. I have to convert them to integers first. And so to do that, this is what is the command I need to do? I'm going to do... so programmer asks, what's that operator? And I can show it right here. So if I do dat3 is equal to dat2, what this is a pipe operator. So I can pipe, so if I do it just like this, this is the same as what I did before. Right? Dat3 is dat2, and so this is sort of a syntax here for sort of composing functions. So dat2 pipe to transmute is equivalent to transmute dat2, like that. But what I need to do is I need to do dat2. What's the dplyr command? Give me 1 second. Look something up. So how's everyone's day going? See if I can get this to work right. Alright, so dat2 so now I'm gonna do filter. So I'm gonna pipe it to filter. Actually, no, I'm going to do not filter, select. And I'm going to select what columns I want. So I want to select, I think I can do x0 to z1, like that terminology. Let's move this down. We don't need this right now. If I do dat3, we can see that I have just the columns I want to modify. Oh, so Peter Little says he built an ice farm based on my testing stream. That's pretty cool. I'm waiting to get back to that ice farm till we can upgrade to on exploit. I may actually do some of that here. What I need to do with Ggplot. That's a good idea. Keep that in mind in my head. And wait until we upgrade and we maybe can test out the lack of block lag, because I kind of like paused working on it because of block lag was pretty bad. I didn't think we'd lose a lot of efficiency if we did that. Okay, so DAT3 has just the columns we want. And I'm gonna see if I think I can do this. Mutate. Yeah. Cross. I think this will work. As integer. Nope. That's throwing me an error. So that's across. What am I looking for syntax-wise? Yeah, should work. Just maybe I don't have the syntax right. Aha. Oh, across everything. See if I can get to see if this one's gonna work for me. Alright, we're gonna try to compose a couple functions. I'm still taking DAT2. I'm selecting all the columns I want, and I'm trying to take all the columns and convert them to integers. There we go. Cool. So now we have our table in the right format we want. So Peter, what was your XP source when you did it? I got the version on Ggplot to work with the Guardian farm, but still, even that, the block lag on the testing server was just so bad for various reasons. So if I did all this correct and I run it, I should have the center of the village in DAT3. So there we go. That is the center of the 3 villages in this world. On it. Oh, so you found a guardian farm next to ice as well. That's cool. Yeah, I like that setup. Ice farm with guardian. It's kind of cool. I think what we'll try today is analyze my local copy of the Ggplot server and see if we can find sort of like all the spawners that are underneath a tundra. So that'll be a good test. And that's cool. So your guardian farm was, you found ocean monument that was below ice. That's cool. Let me go ahead and save this as a note. So we got that saved. On this world. So before I do the next thing, any like questions that people want to see me do while I'm here? I'll take requests, and if it's something I can do within the time of the stream, I'll try to do something related to it. But it's not necessarily like I can't do anything code digging right now. So it's more like, looking for things. I could look for diamonds. I could look for nether rack, netherite, something, stuff like that. One thing I probably should do that I need to be doing is looking for mob spawners that are in frozen tundra. So we had a request for the diamond ones. That's a fun one to do, and I can show you the block API. All right, so we'll do this. We will do the diamonds. So the question is, how about building a farm above the nether roof that doesn't need any roof? So that is a hard coded. You need all mobs in the nether are cave mobs. So if you don't have a roof over it, then you'll have a surface cap, and they have a cap of 0, so nothing's going to spawn. And so yes, Peter, we are looking to see if we can get a good source of XP for our ice farm from mob spawners. For one reason is we have a mob switch on the server, and mob spawners ignore it, but guardians don't. So if we have the mob switch running, we'd have to actually, if we wanted to run the ice farm with XP, we'd have to turn off the mob switch, which doable, yes, but we don't want to necessarily go that route unless if it's possible there's like a good tundra that we can work with, so why not gold farms? They add extra lag. But yes, so we may end up using gold farms. We also kind of feel like gold farms is a bit too easy. Might as well take the challenge and just see if we can build like a perimeter in a tundra with an ice farm in the bottom of it that has things. And so right now, like we're not building, right now on Ggplot, pretty much what we're doing is it's dealing with bedrock, dealing with breaking it or placing it. So once we're kind of done with that and we update, we can see. But okay, so diamonds. People want to know how to find diamonds. Yep, that's about what I did, Peter. I used 2 guardian cells per... I think I used 2... Yeah, per 2 ice trays going back and forth. Yep, I think I ended up with using 2 of the layers. So, bedrock breaking. Dark oak and portals are the only ones I know of that currently work, besides creative mode. And I don't have... In all honesty, there's no reason not to use creative mode and just do it. If you, for the look of it. You know, if you're at the point where, yes, you could start a world in 0.100, delete everything, and then move on, but, yeah. Yeah, portals, Dark Oaks is the easiest, but you can set it up in such a way that the net, where when you go into the Nether, the only place a portal can spawn is a place that will break bedrock. But it is still a bit random, and it's still a bit annoying. And it's best to do that. I need, it's mentioned in the Dark Oak one, but not really described. Maybe if I ever do a portal mechanics video, I'll cover it there. Get it working. Okay, so finding diamonds. Let's find some diamonds. Let's start a new script. So I did this before for my kid. And all right, so we have our database. So I can show you a couple things here. First, let's figure out where our world spawn is. And so to do that, we're gonna do we have our DB path. Let me go ahead and close this DB before I forget. Let's find our world spawn. So we do level dat is equal to, what is it? Read level dat DB path. So level dat, this is our this is reading the MBT data from our level dat file in our world directory. So if I just do names, you can see all the information that's stored in there. And so what we're looking for is world spawn? Is it spawn? I'm trying to remember. Spawn mobs, it's all our setting. I think it's the spawn X, Y, and Z's, in all honesty. Let me see. World start count. Show tags, mob griefing, no. I think it's these three is what I'm looking for. So we'll do level dat. Spawn X. Spawn Y. Spawn Z. Yeah, so that's our spawn. Ignore the Y. So 532, that's our spawn that we want. So I'll do this. I'll do, if I can remember it, spawn X. Actually, we can do it this. We'll get rid of the Y, because who cares? And then we can do, make sure I convert this to as integer. Actually, we'll do it, so that is a list. So we'll do unlist. And then should be good to go. Spawn, we'll say spawn. All right. So I'll have our spawn object, and that tells us it's 504.32, and it's gonna save me a lot of time. if I just record it here as well. This world. All right, so we spawn. So we want to find things, chunks near spawn that have that. So now we're going to open our database again. All right, we're going to now do keys again. Keys is get keys database. Then I'm going to go ahead and parse my chunk key. So I'm going to save it to a value. Let's do chunks. Let's do chunk dat. There we go. Is parse chunk keys. And so if we look at chunk dat now, what it is it's a table like you saw before. Specifically, it's a tibble. But it's tabular data. And so what it's going to tell you is you have your key, and then it's going to have extracted out all the information from the individual things. So you have your X, your Z, your dimension. So 0 is overworld, 1 is nether, 2 is the end. The tag, so this is the this final value. So 44 is equivalent to the chunk version. 45 is 2D maps. 47-0 is the lowest subchunk, etc., etc. So now we're going to take our chunk data and we are going to filter it to find things that are near spawn. So find chunks near spawn. And so to do that, we're going to say dimension is equal to 0. So overall chunks, whose dimension is 0. And let's see, we'll say X minus, so 502, but 502 is actually a chunk coordinate. We need the actual, so 502 is a block coordinate. We need the actual chunk coordinate, and so we're going to do spawn parentheses divided by parentheses, so that's going to give us integer division. So we're looking at our chunks is 31 and 2. So we're going to say our X distance of 31 squared plus Y minus 2 squared. These can, in R, you can use either double asterisk or even a caret to be exponent. And we'll do square root. So we're using Euclidean distance. So this is going to give us our distance from our chunk distance from our spawn chunk. We'll keep it small. Let's do it less than 3. Let's do less than 5. All right. And so that's going to be our first round. So we'll save that to dat, actually. Oops, missing a parentheses somewhere. Filter, parentheses, square root. Oh, right, missing one. We have an extra one. And so what am I doing? Problem filter, input 1, object Y. Oh, not Y, Z. All right, so now we have our dat. So dat should be all of our chunk data that is near our spawn. Oh, hey, old guy. Yeah, you missed me working with villages at the beginning. Sorry about that. And so let me actually do this end. All right. So what have we just done? We took all of our chunk data and we filtered it for all the rows from the overworld that is within 5 chunks of our spawn location, our spawn chunk. Okay. So now where are diamonds? Diamonds happen in the, if I remember correctly, the lower 2 subchunks. Am I right on that? Below 32. Say they're below 32. In Y level. So I'm going to add another filter here. We'll do subtag is less than or equal to 1. All right. And so dat is equal to chunk dat. That's been filtered for the overworld dimension. Chunks that are close to our spawn chunk and the lower 2 subchunks. And so this should work. If I do Control Enter to run it and now look at dat again, I see that we have all of our sort of keys that we want. So now this is the fun part. I can then take our keys and I can do, let's do block dat. Now I'm gonna do get sub chunk blocks data. So I press tab to complete that. I'm gonna do dat keys. What am I doing? Oh, I forgot to put database. Database dat keys. And now we're hitting bug. Get subchunk blocks data. Dat keys. Why are we not? Let's do dat keys. What do we mean? What's wrong? Oh, it's probably because this needs to be dat key. That's what it is. Dat key. There we go. So if we look at this, oh, it's going to be a lot of data. We'll look at the first one. So what is block dat? So block dat is a list of arrays. So 3-dimensional arrays. Each one refers to the blocks in a subchunk. And so if I look at the first one, or actually I think I can do, if I save this to a temporary variable, and then where's my B? I think I can show this. Are you going to show it to me if I look at it? I don't think I can. If I do view B, yeah, it's not gonna give me a nice look of it because it's 3-dimensionals. Let's see how we can show this. So we can access the first element of block dat with a double square brackets. And I'll just say that for B for now. And then let's say we wanted to look at the lowest level, the lowest Y value. So we would do this, B 1, 1, and this gives me a matrix. And if you look through it, vector, you will see that it is all bedrock. Let's simplify things here. I'm gonna do names only. So this is gonna strip off this part of the block information in our output, That's going to make it a little bit easier for us to work with. And we don't lose anything since we're looking for diamonds. All right, so we'll do B again. And now I'm going to do B. And then we see our 16 by 16 first level of blocks. They're all bedrock. Okay. So how do we find diamonds? Well, the easiest thing to do is we say take block data 1 and we ask it if any of the values in block data 1 are equal to a Minecraft diamond. I think it's diamond ore. And that'll return a bunch of true-false values in the same framework. We can eyeball it. Doesn't look like there's lots of diamonds in this one. So we can do, say, sum 4. So there's actually 4 diamond ores. So let's see if we can see where they are in this chunk. So to do that, we would do, if I remember correctly, which I'm going to return array indices. They are true. So what this is going to do is which is going to tell me what parts of this chunk are, this sub-chunk are diamonds. So the coordinates 15, 11, 11, 15, 12, 11. So these are all the coordinates in the chunk that have diamond ore. And so I'm going to save this to an O real quick, temporary variable. Now I need to actually convert this to world coordinates. So this doesn't tell us much. So to do that, so I actually have a command in R and RBedrock to do that. That means sub-chunk chords. O for the indices and the origin of this chunk. And so it's going to be the first one. So let me pull names, block, dat, the first one. Let me go. Let me see. See if I get this right. Yep, and the first one. Let me make sure I'm doing this right. I may need to go fix something. And all right, so we got an error here. That means my subchunk chords function is broken. It's to be potentially expected because I've been doing some API changes. Why am I set non to binary operator? So this is where, let me save this because I may have to come back to this code in 1 second. Make sure I save it. I'll save you because, all right, so now let's figure out what is wrong with my code. Blocks, blocks, blocks. Okay, so for function O is F origins. So I can do it manually real quick and make sure I get this right, because this is where the error is. So Jed's asking about an error in get keys. Jed, if you haven't updated our Bedrock in the last 2 or 3 days, you won't have get keys on it. So this is something that I just pushed like a couple days ago. So you need to install from GitHub again to pull in the get keys function. All right, so let's see what's going on here. So Peter asks, how's my instructional design? You mean for my course in the fall? Well, my course in the fall is in the fall. And so actually it's not actually even until October. So I'm probably not going to start thinking about what it's all going to cover until like 2 days before it starts. Because yeah, that's what we do. It's a thing about syllabi. Everyone always asks faculty for their syllabi, and we're like, yeah, we like to see it too. I typically don't do my syllabus until like the week before the semester starts. Because why? Why do it? Yeah. Alright, so let's get back to trying to figure out why I have this error and fix it. So I knew this was going to happen at some point in the stream. It was stuff I would need to fix, and so I do this on purpose to give you a chance to kind of see how I develop our Bedrock. All right, non-numeric. So what's the is O a non-numeric operator? Type of O. Integer. Okay. That should be so Y. But then that's the origins. Oh, is subchunk origins broken, maybe? What's that? Subchunk origins may be broken. That would make sense. That doesn't return anything. That is our problem. Let's back to box. So subchunk origins. Why? Yeah. So keys. What's going on here? So that is the problem. My music stopped. Let me get some more. Let me get the next one. All right, let's get back. Let's see what's going on. Subchunk origins is not returning anything. So it should. It's this probably the split chunky. Function. Let me close the database. So close the database. Let me go see if this will complain. Let me actually session restart R. So I'm restarting R, and now I'm sort of loading up it to, instead of run R from my global directory, it's not going to load R from RBedrock from the local developmental directory. So I'll do DevTools load all to do that. So let me double check subchunk origins. Now that I've done that, right. So that didn't turn anything. So what's going on? So I'm gonna come over here. I'm gonna run them one at a time. Split chunk keys do somehow. Split chunk keys. At 27, 0, 0, 47 dash 0. All right, so that returns the correct thing. Am I not doing... Maybe that's all I need to do. Now that I look at the code. Maybe it's returning things invisibly. Actually, I don't even do that. I can do... This is what I want to do. DevTools load all. And then do subchunk origins. Boom, there we go. So basically what I was doing is I wasn't returning my value. If I was returning, I was returning it silently. So I changed subchunk origins so it would make that change. And so now we're back to finding diamonds. So let me go through and source everything. Probably it's going in a different order. What are you looking for? You are looking at I don't want to source it. I want to run it. Sorry. All right, so it's still the same problem. Yeah, you're IO locked. Let's try this again. Run you. Okay, good. I'll run that line. All right. Let's see if this is gonna work for us. All right, dimensions. What's up with that? So chunk dat. Sometimes I spelled dimension wrong. That should be fine. Why are we having this error? Is pipe not working? Oh, I haven't loaded Tidyverse. That would help. Yay, we loaded Tidyverse. Now this should be fine. There we go. I was pulling the wrong filter function. Hi, Shady. Right now I'm looking for diamonds. And so... Alright. So with that little bit of fix, block that, test this out. Same error as before. Oh. Post DB. Reload the functions. Did not. Since after I fixed subchunks, I don't think maybe I did reload it. Let's see. Now we got the same problem we had before. Let's do subchunk origins. try this again. Okay, origins. Alright, so that's correct. That was actually not our problem. Alright, back to subchunk chords. Let's see what's up. Let's see, is there something wrong with O? O's there. So this is our function. Let me just make a copy of it here. F. So if I did this right, I should be able to say FO chunk origins and then pass it that string we've been working with, which is here. Well, remember to spell origins. Alright, so we have our error. So error is an F. Non-conform. Oh, now it's a different one. Non-conformable arrays. Alright. Aha, I see what my problem is. Definitely see what my problem is now. I'm going to get rid of this array index equals true in this one because subchunk coordinates is going to do that for us. Okay. So control enter. So now if we look at O, instead of being a 3-dimensional set of coordinates within the block, it's now like a 1-dimension. It does it. And then now we're getting the same error. All right, come on. Non-numeric argument to binary operator. F O. What do we get? FO, our previous one, and now we're gonna do sub chunk. Oops. Sub chunk origins at 270047-0. Non-conformable arrays. So why don't you like me? So, array index. I have a sense it's something very silly. So that's right. Do T. Do that. To transpose it. And then I want to add this to our subchunk origins at 270047-0. Just forgot to misspell origins right. And it's unhappy with me. Should be. Is that because I changed how origins does it? All right. Right, so that is being returned now. Not as a list. I see, I see. think I need to put, because I'm using one value here, I think I need to strip off the, make sure I do this right, the dimensions. There we go. DevTools. Initially close DB. DevTools. Alright, we'll do DevTools. Load all. Alright, so if we did everything right, this should now work for me. And we didn't do everything right. Why are you having problems with me? Let's try again with vector. Let me work here. That'll help me. Let me make a copy of this function, so I can work with stuff here. Alright. So, what I want to do is X is going to be our O that we have before. Y is going to be our subchunk origins of this thing. I know my problem. I know exactly my problem. I know exactly my problem. I've been using subchunk chords wrong as well. I need to do this. Actually, I need to do this. If is character origins. So I've been passing the keys as characters. Well, I didn't write this function to do anything with characters as keys, so that's why all this stuff's been breaking down. But I can make that change real quick. That if it is a character, run subchunk origins as well, not just if it's unspecified. So this little piece of code should convert character names to the subchunk origin. So if you pass in characters. So let me do DevTools. Load all. And then boom. Profit. So these are the location of 4 of the diamonds in my world. Parker Lee, I don't know what you mean by boat puller behavior. So if I clean this up, so that's for one subchunk. What if you want to do this for all of our subchunks that we have in our block data? We can do block dat, and we can use a map. And in this case, we're going to do what we call diamond dat. We're going to pipe block data to map. We're going to create a function. So what map's going to do here is it's going to run this function on every element in the block dat list. And so in that case, we're going to use this as our function. But set here x. So map's going to be like the first time map is run, it'll be run on the first element, then on the second element, then on the third element. So it's a way to run everything together. So if we run that, and we now look at diamond dat, we see that we have a list of integer vectors. So look, this is a nice subchunk. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 diamonds in this subchunk right here. Kind of sweet. Kids would love it. And so what we see is that we have a name. So this is a named list. And probably easier if I do a head, so you can see everything. So this is our named list. And what you have is you have a name that's our chunk coordinate, followed by a list of integers, which are the indices within that subchunk where there are diamonds. Okay. And so now what I'm going to do is I'm going to then pass this to subchunk chords, which, if I have everything written right, should return me a list of where all the diamonds are in this area around my spawn point. So if I try this again, so if I then take, we'll just use this map function again. We'll then pipe this to, after map, we'll then pipe this to subchunk chords, and see what this gives us. I don't know why I'm doing that. Diamond Dat is now has subchunk chords for everything. Now, last thing we can do is row bind, and I think we are in business. And it's going to complain to us. And it's going to, let's do, figure out which is the thing I want to do to bind all these. Because it's matrices. And nope, doesn't do that. Because it's like a list. I think if I do this, do call. I don't like doing it this way. But that gives me what I want. Let's see if I find a better way to do this. So the problem here is that, so we have a list of arrays and trying to bind all those in the list. RBind doesn't do that. It likes like individual arguments. But do call is a way to sort of take a list and pass it as arguments one after a time to RBind. But I don't like it that way. So let me try cleaning up the other way. So that's one way to do it, to get our one final list. Can I just do unlist? Nope, because then that flattens it. Because we have to maintain the dimensions after we do it, which should be bind rows. But that tends to work on data frames. And see, it's going to complain about everything. So then I want to do... Can I just do map DFR? Man, yeah, it's gonna give us the same problem. Alright, so then I could convert them all to tibbles. This is a possibility. You can unlist them, pass them to a matrix, and recreate it. I guess do call RBind's probably the best thing to do. So, so we'll do that. To create our matrix. Now, if I look at it, this is now a list of all the diamonds, however many of them there are. So it's like 174 diamond ores within 5 chunks or so of my spawn spot. So you could do something like this, print it out, give it to your kids, and tell them to have fun finding diamonds. Finding. Yeah, it's like a treasure map. So that's finding diamonds. A little bit of code changes. Let me save this. All right, so where are we? On code. Good, that's still dates. All right, so what do you want to look at next? Anyone got any ideas? So in principle, you could do the same sort of approach for any block that you want. So. What do I want to do next? Okay. All right, let's see what I do. Let's do some graphics next. In this world. Let's do. Actually, let me close my database before I forget. All right, so let's. Oh yeah. Definitely have that code. I don't know if I've adapted it to this. Yeah, so Peter Little says, ask for finding spawner clusters. Yes, I do have code to do that. I probably need to adapt it a bit to the new layout. Don't feel like doing that on this stream. Maybe later. I'm going to do some graphics things. Let me see. Let's go DB path. I'm gonna try to draw the biomes in this world. So I'm gonna try to do something different. We're not going to be able to see it. So let me move this up. Up corner. Yes. I need to update something so there's some background to that thing. Oh well. Yeah. So we'll do the next thing. I'm gonna try to do biomes. And remember our 31 and 2 is our center. Actually, we'll want to use this filter again, so I'll go ahead and copy it. There we go. Will not use subtag. We'll do more than 5. We'll plot it out to 10. Yeah, 10 will give us a good look. All right, so we're gonna look for biomes. Let me start with. All right, we'll get our We'll get our chunk data loaded. What we want is 2D maps. So 2D maps, that's where the biome data is stored. And then, actually, we don't even need to filter it here. We can go here. Okay. So now I'm going to pull the biome data from all these blocks. If I remember correctly, I can do it like this. Dat2 is equal to get biomes data db and dat $key. And if I do head dat2, you see I now have a list of arrays of biomes. You quickly glance through this. So what we need to do is convert this into a basically a table for everything. So to do that, what I need to do is I'm going to map all of our data to see what we can do this right. Dat2 map to well, get our. So what I'm gonna have to do is get the chunks that so I have to get the all these chunks that we have here. I have to get their origins. So to do that, we will do, say, pos is equal to chunk positions names dat2. Names. If I look at this, hopefully, it'll have what I want. Yeah, so that's our array. That's because our chunk pos. That's not our block. Let's see, do I have it converted? Let me go back to my keys function. Let's see, did I write a function to do what I'm trying to do now? Oh, chunk origins, not chunk positions. I thought something was off. Okay, so now if I look at pos, and I have the chunk origins of everything. So, and then I need to convert this to a list so I can use it for the next thing. So, so I believe that function to do that is going to be array branch. It's either going to be array branch or the other one. We'll find out. Yeah, so 32. No, it's not what we want. Looking at the help function, array branch and array tree. And so array tree creates a hierarchical list that has many levels as dimensions. A branch creates a flat list along all mentioned dimensions. Hierarchical tree creates a hierarchical list that has as many levels as dimensions. So one per dimension. Let me see. What am I looking for? Yes, I want array branch. Probably the first dimension. Let's see. Yes, this is exactly what we want. So what I've done is I basically taken every row from chunk origins and turned it into its own element in a list. That's exactly what we want to do in order to pass it to the next function, which is map2. So dat3 is going to equal to map2. So what this is going to do is it's going to run a function over pairs of values. One from dat2, the other one from pos, and we're going to do our function x and y. And so here, x is our array of, x is going to be our array of, what did I say? It's our array of biomes for that chunk. And y is the origin for the chunk. So we have to convert this into a table, is what we're working for. And so our table is, so actually while I'm working on this, let me do, there's dat2, but I'm going to do head. I'm not going to do all of them. I'm going to put a head right in here. So this will only do the first couple elements of dat2. We'll fix that later. All right, so now we're going to do that, and we are going to do, so that's dat function. So that's map. So we have to create a tibble here. So the way to do it is we need to figure out what our x indices are, our z indices are, and so actually, since I'm going to use x and z, I'm going to change this to a and b for the functions. And so actually we got to do head pos too, so it's not going to complain. All right, so head pos, head dat2. All right. So we need to create a matrix. So first, let's think about what our coordinates are for our x's. So our x's, they are going to go from B1 to, we're going to add 0 to 15. And our z's are going to go from B2 plus 0 to 15. All right, so that's going to be the range. Is we're going to go from the first element in B all the way up to 15 beyond it. And that's going to be our x coordinates of our chunk, and z is going to be our z coordinates. And so now we got to turn that into a 2x2 matrix. And so if I do turn this into a grid, x is equal to x, z equals z, and we'll take a break from there and we'll run this and see how it looks. So if I look at dat3, Let's see if I can see it. See if I can view it. Although I'm working in our studio right now, I don't actually use it a whole lot in my when I'm working. So yeah, so we have XZ coordinates. I need to so we need to go back and check the our DAT2 data to see if that's the format. I think it's reversed. I'm gonna do DAT2. DAT2. Yeah, so this is, so R is 0 and is column based. So it's going to go down the X first, which is this first element, like this, and then hit here. So X's have to vary faster than Z's in this grid. So, and so to fix that, well, we just have to know that. That is not a big deal. And so this is going to be the beginning of our return. It's going to be expanded grid. And then we're going to do ret.biome. We'll transpose A. And then that should work. We'll find out if it does. Yep, so that does not like it. Because of the rows. So to do that, then we will do I believe it's as vector. There we go. So this is going to turn it into linear, which works with our data. So data 3, DAT3, head. It's going to give us. Wait, what? Oh, I forgot to. Once again, did it some before. Have to return our result, so it gets passed. All right, so let's try this again. Let me see, we have coordinates and biome. All right. That's looking good. So now we can change this to DFR. And that's going to actually, instead of returning a list of tables, we'll return one big table bound on the rows. And that gives us DAT3. So now we have one row that has a whole bunch of biomes. So we're going to come up here, we're going to remove our heads, and so we're going to do this for our entire area. And this is going to give us our data that we're going to plot. All right, so now we have about 78,000 observations of biomes. So what can we do with this? Before we plot it, I'm going to do a simple table. I'm just going to count what biomes are in my thing. So I'm going to do table. DAT3 shift $biome. And we see that near my spawn point, I have frozen rivers, ice mountains, ice plains, rivers, taigas, and taiga hills. Okay. And now then, let's see if I can plot this. All right, to that, I'm gonna use something called Ggplot. And Ggplot has its own kind of syntax in R, and its own kind of layout. Sometimes it takes me a bit. So I'm gonna say GG is Ggplot. dat3. Yes, so this sets up our mappings. X is X, Y equals Z. This is going to set up our, that when we do a 2D plot, the axis is going to, for our X and Z data, is going to be pulled from our X column of our data and our Z column of our data. And then we want to say our color is going to be pulled from our biome. Let's do fill. I think it's fill. Now we're going to use a plus here to say what we're going to plot. And this time we're going to do, I think we'll do tile geometries. And so what this does is it kind of creates a drawing object. So when we print it, we get the figure. And so if you can see it here, I now have a map down here in the corner that says sort of along the X and the Z. So the Z is actually reversed here. This going down is north for the Z. But you can see that I have a taiga up here on my world. Ice plains, some ice mountains, taiga hills, a river, and then becomes a frozen river. What else do we have down here? Another river, another frozen river, and the ice plains, ice mountains. And then, let me see if I can get the colors. So we can do a couple things. First thing I'm gonna do is I'm gonna try to fix the axes. And then I think I need to do, what's it, scaled? Let's see. Easy. Ggplot, reverse, y-axis. So then I have to search for all the time to remember how to do it. Scale y reverse. That's what scale. So let's. So now we get what we expect in now we get what we expect in looking at like a map, north, south, east, and west. Okay. But our colors are all wrong, right? I do have the colors listed here and in our bedrock. So let me see if I can get the, if I do biome, let me go here, biome list, and our, oops, it's list biomes. I have like a list of all the frozen oceans with IDs and even the color from the game. I haven't done this yet, so let's figure out the best way to link these up for Ggplot. So let me custom color. Let me Google it real quick. Custom color Ggplot fill. So let's see, what's my... Let's see how we're doing with everything. Come on, internet. Do. So I've done that one. Let's see. Let me see. Let me find the command I want to use. Ggplot. Gotcha, so need a... what we're looking for is... I'll pull it up on down here. Help. Scale. Fill. Manual. Alright, so look for a scale color manual. Scale fill manual. Alright. I don't want palette. I want breaks. Maybe it's scale discrete. I know I want aesthetics. I need something that's gonna convert between the name and the color. Okay, so we need to do named vectors right here. This is what we're going to want. So we'll set one of those. We'll build that up from the list biomes. So do that. Let's see. We're going to do... Let's do V. Actually, we'll do color is equal to list biomes color. We'll do set names. We need to give it names. That's going to be from the biome. So we'll do list biomes name. So set names is a function for creating a named vector. So if I do this and I look at it under call, come on, check to me. I'll do it down here. You see that we have a vector of colors. So these are RGB colors. So each one of these is the red, green, and blue hexadecimal values. Each one of these is associated with the name, like plains, desert. I believe if I do this right, I can do scale, fill, manual, values equals call. And this will all do the correct thing. There we go. That is now a map that we're used to looking at in Minecraft. Hello, Kodara. I'm gonna save this little note. And then let's see what I say. Map.r. Might as well. Yeah, so that's our biomaps. We can add some more things to this. That I'd have to look to see how to add. I could do separate points. Let's see if I can quickly. Let me see if I can quickly add some points to this. I'm gonna take a quick 2-minute break. And I'm gonna get a drink of water. And I'll be right back. So I'm back. Um, my internet being iffy again. I'm definitely not hearing any music. Yep, that's loading too. All right, so hopefully, I'm still streaming. We'll find out. Yes, so what this is going to load is just things that are already loaded in the world. And that's what the RBedrock does. It doesn't generate a world for you. You actually have to give it a generated world. And so, see if I can get the music back up. Let's see if we can get this music back up. Okay. Let's see if how well my internet's doing. All right, so that's able to read it, so good. I can see that I posted. But now then, Firefox is unhappy with me. All right, that was good. Let's see if I can play some more music. There we go. And then let me reload. See if that helps. All right. Let's get back to what the questions were. I think my internet's slowly coming. My browsers are slowly coming back up. So far, it's not reporting any streaming issues on my end, but hopefully, we're still here. All right. Hopefully, I'm not just streaming into the void is where I'm paused here. So let me do the last little thing I need to do before I quit today. The last thing I want to do is... Come on, YouTube, wake up. And tell me that I'm still streaming. Come on. Alright, my phone tells me I'm still streaming, so I'm good. I can't see chat right now. My browser's not working with me, but my phone says I'm live. Alright, I'm going to keep going what I'm doing. Hopefully it'll wake up and I'll see chat again. I'll try to pay attention. Alright, so this is, one way to plot biomes in your world. It's for a large scale plot, it's not the most efficient way. There are better, more efficient ways to turn this into pixel data, but I'm not going to go into those today. I'm going to try one last thing, and show you how to find the location of mob spawners in your world, and then we're going to plot them on this map. So the way to do it is I'm going to do, let's see, I don't want to mob spawners, or actually block entities. So we're going to get all the mob spawners that are in this section that we're printing. So block entities, or I'll just say bees. I'll do call them bees. Block entities or bees. We're going to do get block entities data, db, and then we're going to do the keys that we used earlier. And so that's going to be dat key. And what part of these functions do is block entities data is going to take all these keys that are listed, and of the keys in this data set that contain block entity data, it's then going to parse it and return it. So you can parse extra keys, no problem, but it's only going to return values for the block entity keys. And so block entities, these are sort of blocks in the world that have associated MBT data. And they're set up internally as block entities. Some people call them tile entities, but they're internally known as block entities. So that's our bees data. And this is going to be a list of MBT values. So if we look at like bees 1, it's not showing up well. Let's do strings. We're going to convert it to a string. This sometimes allows us to see what's going on better. And it gives us sort of like an MBT data with various different tags like locations and stuff. I can tell this is like a spawner right here. And so the first thing I want to do, so this has a block entities from a whole bunch of chunks. I want to sort of flatten all those together into one list. And to do that, I'm going to do get block entities data flatten, I believe is what I want to do. And now this is going to actually return me one large list of 120, if you look over here, 120 block entities that are in my list. No more so far, no more chats. Let me double check my phone. See if the chats. All right. Some of you are here. I may just be here by myself. All right. But I'll finish this out for anyone who's still watching the stream later. So I've now flattened the stream. I flattened our list. And the next thing I'm going to do is I'm going to filter it. And that's going to be using the keep. Hey Ian, I kind of see your stuff. What I'm doing right now is fighting with YouTube a bit because it's not showing me chat. So that's what I'm mostly doing right now. Slowly trying to finish out the live stream. But YouTube is not happy with me right now. It's still streaming, but it's not showing me my chat. When I refresh, maybe I'll switch to a different browser. Okay, let me log on to YouTube in this browser. Come on, give me YouTube Studio. I don't want it to create a new... I don't want it to create a new live stream. Hopefully this will work. Yay, I'm back. We'll ignore you. Live stream's back up. Okay, this is more comfortable. All right. Yes, to answer your question, Ian, I am fully grounded in R and RBedrock, trying to just sort of go through a stream and go through various different ways to analyze data. In R and RBedrock, right now I'm playing with making maps. Effectively, if you see down here in the lower right corner, this is sort of a map of a world that I play on with my kids a little bit. And you see there's taiga hills, ice plains, ice mountains, all near sort of our spawn point. So right now what I'm doing is I'm finding all the spawners in this area, and I'm gonna map them. I'm gonna add them to this map to kind of show people how to get get like mob spawners. Next one's gonna be, I'm gonna do keep, the keep function. And then I'm gonna pass it dot name. I think this will work. RBedX is not true. Okay, so then that's not what we want. So we'll just start here. I won't flatten it yet. Let me do map these name ID. That's because that's not ID, it's ID. Yeah. So this function map these ID, that's going to return us. If I do it like this, map CTR, that's going to return us the name of everything in... What's up with that? But the name of sort of all of our elements in this list. If that makes sense. So that's going to return us the IDs of everything. We can also do, though, is these keep. Sorry, Jed, you fell behind. It's kind of hard to sort of make a tutorial that people can follow on the fly. Especially when I run into bugs and I have to go fix. And you're not in the same room with me, like a student who would be like, wait, slow down. Also, the two-screen problem is really hard in this sort of environment. All right, so now we're gonna do keep. And then if I remember correctly, mob spawner. I'll explain this little command in a second. Spawners. Once I get it to work. So you are not liking this. Yes, what are we looking for? Keep. Hey, that's what I'm not doing right. I need to do a squiggle. Oh, and that's also a problem because I haven't written some functions to do what I'm trying to do. Yeah, so then that's not gonna work. I need to... So I'm missing a function in my RBedrock API that allows me to do this from the bug report. So we'll do it a separate way. We'll do it back to what we had before. And I want to know we're gonna get we're gonna map to a character, bees, and ID. So this is like a syntactic sugar that's gonna pull all the ID elements out of our block entities. So we'll just say that to a vector called IDs. So now everything got converted to a character. You see all of these. Now, if I say IDs is equal to mob spawner, we get a whole bunch of true false values. So this is going to tell us, this is going to be a vector. IDs equals mob spawner is going to be a vector of true false values that we can now then use to subset our bees. If I do this, we'll comment out that code since it's not going to currently work. Then we see our spawners. We get 11 information. We get 11 things with mob spawners. Now, what I want to do is I want to try to turn this back into a table like we did earlier with our village data. And so to do that, if you remember, we want to map this DFR unclass. So what unclass is going to do is it's going to sort of strip off our class information. So it's going to basically strip off this information that we're dealing with MBT data, and it'll go back to like the raw list data. And that's going to allow map DFR to work with it properly. And then so now we can look, and we now got spawner data. A table of spawner data. We got entities, max spawner delays, min spawner delays, all this sort of information. What you can note about this is that you can go in with an MBT editor in your world. Let's say you're making a custom map and like really change up spawners. Like, you can make them spawn from way off. You can make them spawn a lot and spawn in a wide range. You can even make them spawn fast. Like, really, like, pump out the mobs. And you can see current delays. Looks like we had one of them that was accessed recently. A zombie spawner that was activated recently. And what's important for us right now is our X and Z values. So we are going to, let's see if we can get this spawner data added to our map. Remember how to do it. So we're going to use GG. This is our map from before. We're going to add to it a... What am I looking for? I'm looking for... I forget the command. An annotation. Alright, I think I did it like this. Point. X is equal to, it's point. Try point, I forget. I can actually test this out real quick. G point, there we go. We want to do point. It's going to add points with the values of X is going to be equal to spawners. $sign X for the X column in spawners, and Y spawners. Actually, let me make this a new see what I'm doing. And spawners Z. If I do this right, I can then do print GG, and I'll get a new plot. Make sure we convert this to integers. This is basically going to strip off the class data on this. I gotta recreate it here. So let me copy this. Let's just make it easier to work with. Delete that. It's annoying. There we go. There is the map of this part of the world with the location of spawners. Each spawner indicates. So we actually have, if I look at 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I might as well put in, what did we have earlier? We have, yeah, and I believe so if you look at the center, so it's going to be like 32 and 2 and 0, so like 500 something. It's going to be like right around in here is the location of my spawn. Actually, if I just did it, it's right in the center. It's going to be here. And here-ish, it looks like. Is where the spawn location is for this world. I do know that I think these are 2 zombie spawners that are within spawn distance of one another. So I may end up building that one day on stream with my kids as a double spawner. And so if I did one more change up, let's see if I can. Let's see if I can. Bill is going to be. Let's see. Wait, what's the spawners? What do we want? Entity identifier. That's what we want. As character. Entity identifier. If I did this right. Try this again. If this works for me. Okay. Known color name. I'm trying to use it as a color name. As factor. Maybe I'll do it if I do it as a factor. Let's see if that works for me. And I'll explain it in 1 second. So it didn't complain. Oh, it does. It still complains. So what if I do color? I may need to do something else to do what I want to do here. I'm trying to color each of our points differently. Yeah, it's not good. It's not happy with me. All right. So then I will need to give me 1 second. We're gonna do color. Let's do. Gotta see what all the different ones are. A quick, unique. spawner anti-identifiers, spiders, zombies, and skeletons. So, and then once we have spiders, zombies, and skeletons, we're gonna do. We're gonna make a little named vector color map kind of thing. And we're gonna do S color is gonna equal to we'll do red. And then Minecraft is equal to gray. Let's see how this looks. And then we're gonna do scall. And we're gonna do spawner, scolor, not scolor, as character, spawner, shift, into identifiers. All right, so we're creating a vector, a named vector, and then we're gonna take that and basically what this it's gonna do here is it's gonna match the names, and so we're gonna get, if we look at scall now, colors that correspond to our spawner types. And so if we do this correctly, if I've done everything correctly, let me try this again. Is this call really that long? No. No, that's fine. Let me move this up and get it out of the way. Oh, scall, that's what my problem was. Alright, so we're gonna make our GG again. And we're gonna do it again. If I print it, we now see our alright, so these were skeleton ones. So we got a spider here, 3 zombies here, 2 more zombies, skeletons, spawners. And yeah. Hi, Micah. You get used to it. It is nice at times to have 0 indexes when you're dealing with like coordinates and stuff, and it is a bit weird when you're trying to convert between like internal bedrock data structures that are 0 based, like with coordinates and stuff, to R, but works okay. So yeah, so this is me plotting all the colors with that on for the spawners within this part of the world as points. So I think I'm going to end the stream here. So if there's anything you want me to see about, analysis of an existing world, be sure to ask in the comments, join my Discord, ask in R and RBedrock. We kind of, get a list of things going that maybe I could do more streams like this, hopefully build up people having better skills with R and RBedrock. Also helps me uncover things such as this working with MBT data, such as this not working, and like it used to. And that has to do with me not implementing certain functions yet. and know kind of what to do to fix it. So hopefully you've all enjoyed the stream. I've enjoyed sort of working through things, making changes to the code base as I go, and plotting some of these data sets. All right. Like I said, if you have any questions about certain things that you want to do, ask in the comments below or in my Discord, and we'll see. Cheers.